Okay. All right. So yes, this is from a simple tailoring experience. You can see that, even though the processes is not as complicated as engineering, if we really go through that, it is actually the end product that you are looking at will be generally good. You see, it's supposed to be good because you have gone through the whole process of looking into the materials, machineries, methods, and all that. So PQP, we are looking into that. Unfortunately, like I say, a lot of engineers, when they do PQP, they think of it as a standard. They copy specification into the PQP, and then they ask the contractor to come up with the work method statement so that they can complete their PQP. I mean, hello, and then everybody is supposed to follow that stupid silly documents that doesn't make sense to anybody anyway, so it's wrong. So when you do PQP, if you need to have a whole group to come together to do the PQP, you should do that. And the format, like I said, you go from your work breakdown to the standards that you're supposed to be using, to the specification that you may be using, then to go on and use the uh, look into the methods of work. If you need a contractor to come and help with that, then by all means bring them into the team. And then you look into the materials and you look into the quality, what you want from this component, you see. So if you need a special gold scissors, then you specify it there. You need a special gold scissors. If you need a special machine to do the trimming and all that, you must specify that. So you see, when you specify that in quantitative manner, it will help, you see. So the other portion of all this is the checking. Unfortunately, a lot of PQP don't have checking. They just say that, okay, you must inspect, okay. So what you have in a PQP, not only you have all the plannings of the material, the methods, the machineries, you must also have the control, the monitoring. So who is going to do the purchase, what sort of purchasing is supposed to be done, how you're going to do purchasing, and what sort of inspection and what sort of forms you're supposed to fill, and then what sort of calculation that you need to do in order to calculate you meet the requirement or not. So a lot of ticking the numbers and all that. So we can use things like checklists, we can use things like bars, histogram bars and all that. You can use calculations, like some software sometimes, SPSS and all that. There is a lot of methods that you can use to actually do monitoring. So monitoring is usually it's like recording. It's like recording the numbers, recording the items down carefully in that sense. And then after that, controlling bit is the one that you must do checking and monitoring. Because checking is also C. So people say QC, they say quality check. Actually, quality check is like monitoring. You're actually recording the numbers down. You're actually recording what you see on site, what is the result of the items that you built and all that. It is from there that you do that recording. So quality check, quality recording, quality monitoring, they are all about the same thing, okay. Then after that, the monitoring bit is the final control bit. Is you can actually input those data into a lot of these statistical like scatter diagrams, like control chart, like histogram, like bar chart. All these are different ways of actually making sense of the data that you collected. There's no point of collecting certain data and keep it in the files, like you have tons and tons and tons and tons and quality papers, that you keep, but then at the end of the day you don't know what it means, and then and you can't find the root of the problem, whereby if there's a quality issue, this keeps on coming out, it keeps on appearing, so it becomes it defeats the whole purpose, okay. So when we do that, we really want to make sure that you have somebody who actually study the data that is being brought back. So in the whole process like this, okay, it all should be stated in your PQP. So that quality manual that you have, okay, it is actually pretty much it is actually pretty much there in the it is pretty much the whole practical process of the work that is supposed to be done. So if you talk about your TQM, you should have this, and this should be a very comprehensive document. And then back to your initial mission and vision, your objectives, it should fulfill that. Let me open my files again for this one. So let's move back to this particular section. So here, yes. So yes, you see, so these are some of the quality tools that we're talking about here, okay, that you can use, like benchmarking. Look at what other people has done and see if you can improve on that, or you can look at other projects, okay, benchmarking. And yes, do cost benefit analysis sometimes. This is very important when we talk about cost benefit analysis. It's like, you want to have so good a quality, but the cost bit is going to be suffering, so it has to be balanced. There are some quality that may not be attainable with the level of cost that is available. So your client must understand that, okay? So it must be optimum. You cannot have perfect. You cannot have no project, okay? And dear engineers, all of you, you must understand that no design will be perfect, no construction will be perfect. So if you want to go for perfection, you have to make sure that you have lots and lots of gold and money involved, okay? Why? There is always a cutoff point. There's always what we call an optimum point. Otherwise, for that too much money you are spending on improving quality by just 5%. So you want to be within the 95, 93, 97, that particular level of quality requirement. And in order to improve on that 5% or 3%, if it's taking up extra 30% of the cost, then it's not worth it anymore, okay? So we must find a balance. I think this is something that is in I think it's in one of the gurus talking this. In one of the gurus' concepts, it's either Tagaguchi or Duran. Either one of this person, he talks about the cost of quality. You cannot be up to perfection, and you must understand that. And you, as engineers, we must not force it. We must not force it. It's wrong, because it's impossible to attain without the cost suffering, okay? And then flow chart. I really love flow chart. So from your PQP, do flow chart, do lots of flow chart, do the whole process in the flow chart, and then put there what is the material, what is the machinery. It's actually combining the 3 M's together in a very nice, easy to understand manner. And if it fails, you do what checking, and then from that checking, if it fails, what do? You go back to which level. So I think if you do your IDP and quality management, do flow charts. If you do your PM assignments, do flow charts, lots of flow charts. Every processes do flow charts. The flow charts that you do is going to be really easily readable, understandable, and you just have to describe the flow chart a little bit. It really encompasses everything that I say, from having the standards, the work breakdown, to the standards, to the material, to the machineries, to the methods, to the checking, to the monitoring, finally to the controlling. All this can be shown in a flow chart, okay? Design of experiments, of course, is about some part of it you need to check what's you need to put in the what you call the standards. So the metrics, the numbers. So those numbers, you have to be sure why you need that numbers, and it comes from design of experiment, okay? So this is output in terms of quality. All right, so here, okay, let me stop here.